Hey everyone, this is FixReef, and today we have another Apex DOS for repair. This one actually came in as just a board with yet another DOS that I was fixing. So there were two of them, and this is just a board, so there is not a motor attached to it or anything else. But we have another unit we can connect to for testing. But this board came in with clearly an issue of water damage over in this corner here. So, and it does not work. To see what's going on, I am going to there is clearly water damage here, and I know that it's going to cause issues. Like, for example, there is significant corrosion on this voltage regulator over here. But after cleaning a bit of corrosion, I'm just going to plug it in to find out if there is anything that's shorted or right away that's wrong. There is probably going to be quite a few components here that will have to be either cleaned up or replaced. So let's give it a lab power supply. It's not connected to anything at this point. And I'm expecting if anything works, there are two LEDs here that glow either blue or orange or yellow. They're supposed to light up if things work. Let's plug it in to power. Let's give it a little bit of current off of the bench power supply, see what it does. Oh, and right away we see some smoke coming out of it. So there is definitely a short. There is a lot of water damage here. So, okay, so what I'm going to do first is I'm going to look at it under the microscope, maybe clean up large amounts of corrosion. Then we'll throw it in the ultrasonic cleaner. It'll come out of it and see what we got. Okay, let's do the initial examination. So the smoke came from this part of one of the 24-volt outlets. There's clearly a short in here somewhere. The problem is that this is not just a 24-volt output, this is an Aquabus output, so there is going to be some data exchange as well. So we'll have to clean this all up, maybe even potentially replace the connector. But for now, I'm just going to get rid of as much of this burned plastic as I can. Okay, so and there's going to be some damage to the PCB as well. Next up is going to be the 12-volt regular Aquabus port, double port actually. Also has some corrosion, will need to be cleaned up. May not be as bad. Then we have what appears to be the 5-volt CAN transceiver, guaranteed to be blown at this point. So if it's all to work, will have to be replaced. I am not sure what's going on with these two places where the diodes are supposed to be. I'm pretty sure that there's supposed to be 3 diodes in this area, so I may have to find replacements for those diodes. More oxidation on this diode. Let's see what else. This is the voltage regulator. Another 3 diodes, but these are looking much better. This capacitor has a little bit of corrosion around it, but not particularly bad. And this is the 5-volt voltage regulator that's definitely corroded and will more than likely have to be replaced as well. A lot of oxidation on this particular component, unfortunately. And we have the main controller is the big question right now, whether or not it actually works. Because the main controller gets power from the voltage regulator. The voltage regulator has been clearly damaged. If it's shorted and send more than 12 volts down the controller line, that controller is dead. Okay. What's going on? Let's see what's going on with these traces. So these are the data traces going into the connector. And probably on the other side, there are going to be power traces. And I really don't like the fact that there is so much damage on the main board here, because when it gets this damaged, there are going to be shorts everywhere. This trace came off already. Okay, let's see what's on the other side of this. Okay, the USB connector doesn't look too bad. This is that 24 volt connector that's shorted. There's ground and power, but the other side doesn't look too bad at all. Does not look too bad at all. Okay. I think the biggest question is going to be this connector over here and the main controller. The rest is doable. Okay. All right, now that the most of the surface is roughly cleaned, it needs to go into the ultrasonic cleaner for a really, really good scrub. Actually, before the ultrasonic, I'm going to go ahead and remove this port over here, because this port is going to be the one causing most of the trouble in the initial stages of the repair. Okay. I'm just going to attempt to remove it with just this. It may or may not work. The idea is, much like we do with most of the larger component repairs, the through-hole repairs, is to add quite a bit of leaded solder to lower the overall temperature and increase the surface. Nice and easy. Now let's take a look inside, because this is going to be, this is likely going to be a challenge. Okay, so this is the surface area we get to work with. So power clearly comes off of this trace over here. And there is a short throughout this board. The short is probably to the going into the ground. That's the whole reason, but for the problem. So it's not going to be as bad as long as we can clear the short. I think it's reasonable to expect that this will continue to work. There is just a whole lot of burned board. Okay, and that's the crater we have. So there is clearly a short at the 24 volt line that caused all of this damage. And let's see if the short is gone, because the damage is only on this side of the board. So hopefully, if the board itself is not shorting now between this and the ground, we might be out of the woods, at least on this connector. There is absolutely no issues here anymore. Great. Now this can go into the ultrasonic, have everything cleaned up, And then we will measure the resistance again around this area to make sure that everything is cleaned up. All right, so the board is back from the ultrasonic cleaner. And honestly, if not for this gigantic crater over here, you couldn't tell that there was any water damage. All of the corrosion is gone. It did expose the metal elements or copper elements that where the solder was eaten away with the corrosion, but other than that, the board is in a very, very good shape. I also put the connector through the cleaner, and even the connector looks very nice. Nice and clean. All of the oxidation is gone from it. So we're probably going to be able to save the connector, but the question is, are we going to be able to save the board? Because quite honestly, this crater concerns me in that are we going to be able to restore this to the point where it's going to work? For now, I'm just going to hold off on this connector. I'm not going to restore it yet. And I'm going to check out other components that we have here. Namely, the first suspect is this voltage regulator. This is a 5-volt voltage regulator that likely is blown as well because it had a lot of corrosion on it. Let me zoom in. Okay, so first off, there's supposed to be a short across this too, and there is. There shouldn't be any shorts across this, and there is none, and there shouldn't be any short across this, and there is none. Well, it doesn't mean that the voltage regulator is good. It just means that it doesn't have a short. It doesn't mean that it actually works the way it's supposed to. Okay. Well, with this removed and the short gone, and most of the board cleaned up, let's now plug it into power and see if anything immediately heats up. All right, lab power supply, and off we go. Let's see if there is any smoke. No smoke. It's consuming a little bit of power, but clearly none of these LEDs light up, which means that there is an issue somewhere, somehow. Let's check basic voltages. All right, let's see what we get here. 5 volts. Wow. Twelve volts. 5 and 12, so the voltage regulator actually works. That's very nice. All right, what else? So we get power to 12 volt, we get power to 5 volt, down to 5 volt. So that's encouraging. That means that the circuit, as butchered as it is, actually works. However, there are no lights. Let's see what this does. Okay, so it appears that we don't get any power on the controller, and there is not even at this larger capacitor any voltage that exists. Whereas this one does have 12 volts, but this one does not. I'll get under the microscope and make sure that the voltage regulator actually creates the 5 volt power that it claims that it does. Because often what happens is that especially after the ultrasonic cleaner, the remaining copper and solder is gone, and there is nothing that's gonna hold the spins. Like this, for example, this pin right now is moving, so there is no connectivity to the board. So is this. Because there is no connectivity to the board, there is no voltage being applied. So here's what I'm gonna do. I'll disconnect everything. And I'm going to the regulator seems to be working, but it's definitely corroded. So we're gonna remove it and reflow it so that it stays in place. Okay, now that the voltage regulator is gone, I'm going to go ahead and clean up all of the pads and make sure they're back to their shiny new state. It's starting to look better and better. Excellent. Most of the pad is still salvageable, or so I hope. Let's see if it will take some solder. This one is particularly concerning. Oh yeah, very, very nice. The pads are all good. Okay, need to clean up all the mess. Looks almost brand new. Now, of course, the challenge is the voltage regulator itself. It's got a couple of pins that can use some good cleaning. Okay, it's as clean as it's going to be. Let's see if we can put it back on. We do need quite a bit of flux. Yeah, look at it. As good as new. While I'm at it, I'm going to also fix this capacitor here, because it looks like it's also partially disconnected from the trace. This capacitor has nothing to do with the voltage regulator, not a whole anyway, not a whole lot. But it does have to do with the 12 volt aqua bus input. See if we can make it stay in place. Okay. Now it's nice and solid, it's not moving anywhere, and hopefully connection is solid. I still need to replace these diodes over here. I need to find ones that are going to be appropriate for this application. But while we're at it, we might as well clean everything up and prepare the pads. Beautiful. Yeah, the damage is definitely just surface damage. The pads are pretty good and ready to accept the solder. Beautiful. Now, I have absolutely no faith in the CAN transceiver here, so I'm not even touching it. It is about 99% certainty that this transceiver will have to be replaced anyway. Let's see what's going on with this remaining diode. Yeah, this diode is also moving and shifting, and I'll remove it and clean things up. Yeah, as you can see, one of the pads is completely gone. Well, not completely gone, but solder from it is completely gone. And all what's left is oxidized metal. And look at it. As good as new. As good as new. As good as new. All right. Okay, now that we have a fairly decent resistance across the data pins and very, very good resistance across the power pins, we're going to attempt to reinstall the connector. The challenge, of course, is going to be the power pin going to this, because the power pin is the one that's going to have to be soldered on the inside because of the way the connector is built. So the way I'm proposing to do this is attach a wire to the pin first on the connector. Nice thick copper wire. Let it stick out, and then solder it to the remainder of this trace. Let's see if this wire would be thick enough. Oh yeah, or maybe something even like this. This is definitely thick enough. Okay, so the goal is to have a wire attached to this pin. This is the power pin. And then let it stick out and then attach that, the other end of that wire, over to the trace. See if we can make it happen. Now just cut off the excess. Okay, so something like that. Now it's a good idea to add some solder to all of the remaining pins or traces. Okay, the connector is installed. Now the hardest part. Because we need to solder this. So I need to expose more of the trace. Some flux and see if we can get it done. I'm definitely using a much smaller tip for this one. And that's it. Okay, the remaining challenge is going to be attaching the data pin. And now I'm going to just apply some more conformal coating to this side. Okay, now this needs to be UV treated. All right, so I'm replacing the transceiver because that's the next thing to do. Needs to go this way. And we need some flux. As I was removing and cleaning up the old transceiver, one of the pads came off. It's fairly typical given the condition of this board, of this side of the board anyway. We're going to be able to still connect it properly. Not that big of a deal. That was pretty quick. Beautiful. This is a data trace, so it doesn't matter the thickness anyway. Okay, and it's not going anywhere. I'm actually going to add a little bit more solder to one pin that kind of looks dry. That's it. Now, last but not least, would be the controller. But before I replace the controller, I'm going to plug it in one more time, just to make sure nothing's going to smoke on me. Okay, let's give it some power. And on. So far, so good. The controller is still heating up significantly, so the controller is dead. Okay, let's remove this controller first, noting that the first corner pin is over in the upper right corner. I'm going to add quite a bit of flux. And let's get it off. And it's off. Since there is no corrosion on this, I'm just going to clean up all of the pads real quick and nice and clean. Replace it with good leaded solder. Okay. Okay, that's good. Let's put some good solder on it. Okay. Ready for the new one. All right, let's get a new controller. Before we install it, more flux. Well, I can easily see this. Position it properly. And let's put it in place. Okay, it's not fully aligned. It's not that big of a deal. Surface tension is going to take care of alignment as long as we are mostly there. Let's heat up the board. And there it is. All right, everything's cooled off. Now let's clean up. Everything is super hot. Okay, so replaced the CAN transceiver and replaced the main controller, the main CPU. And what else didn't we replace on this board so far? Okay, so currently this CPU has absolutely no software, no code, no flash in it, no firmware in it, I should say. So I'm not expecting it to work properly. I'm not expecting the lights to turn on. I'm not expecting anything else to happen here. But I am hopefully going to get a lot less current consumption if I were to plug it into power right now, because it would just be sitting there doing nothing, waiting for the code to be loaded. Let's see what happens. Power on, and the consumption is drastically lower. So by removing and replacing the main controller, main CPU, we got rid of whatever short was causing higher power consumption. Now it's time to reprogram this and see if we can get the lights to come on. So to program this, I'm going to use my development board. Once again, you don't need to have a monstrosity like this. You can get a small, cheap Chinese programming device if you need to. The point is that each Apex unit comes with the ISP connector over here that allows you to program things fairly easily. So I'm going to go ahead and connect it. Let's give it some power. So far, so good. It looks like we got green lights indicating that the power is good and connecting, and the device is working properly. Let's program the flash first. Now let's program the EEPROM. And to avoid all of this blinking there rapidly, we need to set the fuses properly. And here come the fuses. Okay, everything's programmed. Now I'm going to disconnect it from the programmer. Let's give it some power, and let's see if we get the blinking lights. Looking for yellow, orange blinking lights here. Hey, would you look at this? It's actually working. It spins both of them. Well, that's wonderful. So the last thing we need to do is just make sure that it's working through the controller. Okay, so to test for Apex head unit connectivity, let's give it some power. Let's plug it into the head unit. Well, now we're going to give it some power. Let's see if the lights are going to go solid. And the lights are solid. All right, let's test. Manual priming works perfect. Let's see if we now can get it in a list of devices, our list of modules. Very good. DOS shows up with the version 7 loaded. Let's put some controls on the board. And let's see if they work. Here comes pump number 1. And it's spinning. And pump number 2. And it's spinning as well. Wonderful. All right. Well, another Apex DOS fixed. In this one, we definitely had some significant water damage. On one side, we had to replace some missing diodes. We had to replace the CAN transceiver. There was a lot of damage on the 24 volt one link connector, which had to be cleaned up, and it had to be resoldered, and traces had to be rerun around the board to avoid future problems. A few more issues here related to the voltage regulator being corroded. But the biggest problem was the fact that the main controller, the brain of this unit, was also shorted and damaged, and that had to be replaced. It had to be reflashed with the new firmware and reconfigured. But at the end, it appears that this unit is working, and that's awesome. Well, if you enjoyed this video, please like and subscribe, and I will see you next time.